about the alternating series test. An easy example of an alternating series test is 1 minus 1/2 plus 1/3 minus 1/4 plus 1/5, etc. We notice that the signs alternate from minus to plus, minus to plus. If we compress this series, we get the formula of the sum of n equals 1 to infinity, negative 1 to the n plus 1 times 1 over n. When we look at the series, this negative 1 to some power indicates an alternating series test because the signs change. And the number next to it indicates the b sub n. In an alternating series test, the sum oscillates back and forth. So, in this case, 1 is b of 1, then negative 1/2 is smaller, the third expression smaller than that, and the next one smaller than the one before that. And it goes on back and forth until it converges to a number. To prove or test for convergence or divergence of an alternating series test, it must meet two criteria. For one, the b sub n plus 1 has to be less than or equal to the b sub n. And in this case, whenever you look at a series, the b sub n is whatever comes after your negative 1 to some power. And the second criteria is that the limit as n approaches infinity of b sub n equals 0. And if these both are true, then it converges to a sum, which is typically 0. From the textbook, we have a couple of examples from section 12.5, question 7. You have to test for convergence or divergence. So, question 7 reads, the sum of n equals 1 to infinity of negative 1 to the n power times 3n minus 1 over 2n plus 1. So, for the first criteria, b sub n plus 1 is less than or equal to b sub n. If you plug in the consecutive numbers starting from 1, you get negative 2 over 3 if you plug in 1 for each n. Then for n equals 2, you get positive 5 over 5, or 1. If you plug in 3, you get negative 8 over 7. Also notice that as n increases, the signs alternate from negative to positive, negative to positive. But what we notice is that each consecutive b sub n plus 1, the numbers increase, they don't decrease. So the alternating series test diverges because it does not decrease. And you don't even have to go on to the second criteria because you know that it won't approach infinity. Approach 0. For question 9, the question reads, the sum of n equals 1 to infinity, negative 1 to some n power, times n over 10 to the nth. And for the first criteria, you have b sub n plus 1 is less than or equal to b sub n. If you plug in each n, starting from 1, going to infinity, and if you do the first couple terms, you get negative 1 over 10, plus 2 over 100, minus 3 over 1,000, plus 4 over 10,000, etc. So the function decreases. And also note that whenever you look at b sub n plus 1, you're looking at the absolute values of each number. It doesn't matter if the numbers are negative or positive, but if you separate each one, you notice that 1 over 10 is greater than 2 over 100, which is greater over 3 over 1,000. And then for the second criteria, the limit as n approaches infinity, b sub n equals 0, the denominator becomes large, so the limit goes to 0. You can notice this by 1 over 10 is greater than 4 over 10,000, and the larger the denominator gets, the closer it gets to 0. This series meets both criteria, so therefore the series converges. And for question 3, you have to test the series for convergence or divergence giving this series. 4 over 7 minus 4 over 8 plus 4 over 9 minus 4 over 10 plus 4 over 11 minus etc. And so if you compress this formula, you get the sum of n equals 1 to infinity of negative 1 to n plus 1 times 4 over n plus 6. And if you notice that, you'll notice that the b sub n's plus 1 are less than or equal to the b sub n. And this formula works because if you were to plug in the numbers starting from 1, you would get negative 1 to the 1 plus 1 power times 4 over 1 plus 6, which is equal to positive 4 over 7. And if you were to plug it in for the second number, you would get negative 1 to 2 plus 1 times 4 over 2 plus 6, which is also equal to negative 4 over 8. So that holds true for this equation. And so if you look at the absolute values of each number, they decrease because 4 over 7 is greater than 4 over 8, which is greater than 4 over 9. So therefore this function decreases. And then the second criteria is to look as the limit of n approaches infinity of b sub n equals 0. We notice that if you plug in numbers, this limit gets infinitely small and it converges to 0. The reason for this is because the numerator stays constant, but this denominator is going to infinity, which means that this series will go to 0 as the denominator increases. So this series converges because it meets both criteria. And there you have it. Now you can solve alternating series questions. Thank you.